determine the average amount of growth of a child from time 5 to 10 years. I should have put a little bit more words in here, but this is actually going to be an estimate. I should have put the word estimate in here. If they tell me average amount of growth, average value, this is really average value. Okay, if you want the average of anything, the average amount of growth. Now, it's different from average rate of change. Make sure you understand, this has no word rate in it, so that's different. If you want average rate of change, you guys learned last semester that this is the formula for average rate of change. Okay, this is not average rate of change. This is just average value. Do you guys see the average of G? So average of G, okay, is 1 over B minus A, the integral from A to B of your G. If you want average of G, okay, you would put G right here, okay? This is average value, the average amount of something, okay? What is my B going to be, okay? What is my A going to be? All right, so I'm going to replace all of these. Make sure you don't switch them around. If you switch them around, you'll get the negative answer. Okay, so that's 1 over 5, 510 GT dt. Okay, so this is all I have. I know this is the formula, and I've got some numbers for G. Okay, well, let me think about this. What am I going to do here? Let me just, if I have a table, I'm just going to go ahead and plot it and see what happens. I've got some numbers for G. So G at 4, G at 5 is 4. Okay, then G at 5.5 is 3. G at 8 is 2. And G at 10 is 5. Okay, and this is a G graph. All right, if I'm trying to plug into this formula, yeah.
Does it make a difference when you put, like, if you put your 5 and 10 on the top or the bottom?
This 5 right here, yes. Yeah, if you switch these, then you better switch these. That's the only thing. Does that make sense? So it doesn't matter. Like if you call this your B and this your A, right? Just be consistent. This has got to be your B and this has got to be your A, as long as you plug in the formula correctly. Does that make sense? But you can't switch, like you can't call this your A, but then put this number, you know, like you can't call this your B and then put this number here. Does that make sense? It's just got to be consistent. Whatever you call A needs to just stay A. Whatever you call B needs to stay B. Okay, and it's got to plug into this formula. Okay, so let me ask you, if this is a form for average value, 1/5 is pretty easy. How do I figure out what this is? How do I figure out what this is? Yeah, it's a Riemann sum. Do you see, it's just the area under the curve. Isn't this the area under the G curve? And this is the G curve here. I know it's not a curve, but I can estimate it, okay? And I'm going to use a trapezoid method. You guys don't have to use a trapezoid method. You can use a left hand or a right hand, but the trapezoid method is going to give you the answer that I gave you. Okay, so this is a trapezoid method. I only want to go between 5 and 10. These are my limits here, 5 to 10. And so I want these 3 areas. I have the first trapezoid, the second trapezoid, and the third trapezoid. And this is a good review also on the trapezoid method. So for the first trapezoid, the formula is the average of the bases times the height. So do you see the basis is 4 plus 3? The average is 4 plus 3 divided by 2. Guys, average is not 4 times 3 divided by 2. Is everybody good with that? Average is not multiplication. Average is you add them together and you divide by 2, okay? And then you multiply by the height, which is the length of your rectangle, basically, the length of your trapezoid here. So what is that length going to be? Do you see it? Do you see that it's 0.5? Is everybody good with that? Which is really 1/2. I'm going to put 1/2 here because I can actually multiply this. This is 7 over 2 times 1/2, which is 7 over 4. Okay, so that's my first area, 7 over 4. Okay, my second area for the trapezoid is going to be the average of the bases, but what are the bases on my second trapezoid? 3 plus 2, right? Divided by 2. Okay, averages is adding them together, dividing them by 2. And then I'm going to find the height of my trapezoid here, or I guess the length of this subinterval. What is the length of this subinterval? 2.5, right? So this is going to be times 2.5. 2.5 is really 5/2. You have a calculator for this, so you can use a calculator if you want, but I'm just letting you know I'm doing it by hand, so I'm changing it to 5/2. So that's 5 over 2 times 5 over 2. So I'm getting 25 over 4. Okay, so my first trapezoid was 7 over 4. My second trapezoid is 25 over 4. These are the areas of the trapezoid. My third trapezoid is going to be this base plus this base divided by 2. So do you see that that's 2 plus 5 divided by 2? Okay, how do I get the length here, guys? 10 minus 8, right? Which is 2. Okay, these 2's are going to cancel out. So I get 7. Okay, so I add these numbers together. So 7 over 4 plus 25 over 4. Is this actually right, 2 and 5? Yeah, that is right. Okay, and then plus, let me get 28 over 4. I am just trying to add fractions without a calculator. So that's going to be 53 plus 7, which is 60 over 4. So I get 30 over 2, which is 15. Okay, be careful though. 15 is not the answer because 15 is, it's just the area under the curve, right, from 5 to 10. It's the area under G from 5 to 10. You guys agree that that's 15. But what do I need to do with it to get the average value? Divide by 5 or multiply by 1/5. So my answer actually is going to be 3. Okay, so the average value is 3. And see if that makes sense. Remember what average value is? Take this thing and color it in. Okay, put cereal right here. Put cereal right here. And if you push it down, would it make sense that 3 is a value? Would that make sense? Make sure it makes sense, right? Would it make sense that 3 is possibly a value? Yes. Would it make sense that 15 is a value? No. Does that make sense? Okay, so make sure that your problem answer makes sense. All right, so that's number 4. Someone else asked about, I think it was number 9. So let me go to number 9.
It was number 9 on 2 nights ago homework.
Oh, number 9 on 2 nights ago?
Yeah.
Okay, number 9 on 2 nights ago. So let me,
Miss Chang,
Yeah.
I had a question about that one.
number 9 on 2 nights ago?
No, the one you just did.
Oh, the one I just did.
So you couldn't do the f of b minus f of a because it's
Yes.
not the derivative,
Yes,
correct?
okay, yeah, no, that's a great question. Now I lost my number, so I don't know where it is. Let me find it. Let me try to find it again. Is it right here? Yeah, it's right here. Okay, that's a great question. Let's say, why didn't I use the first fundamental theorem here? Okay, let me make sure you understand. The first fundamental theorem is, remember, the antiderivative. I didn't do my little dance for you guys, so you guys didn't see that it was the antiderivative, and I think we'll have time to do it today. But the first fundamental theorem, if I just wanted this blue box here, okay, this would be equal to the antiderivative of G. Well, what is the antiderivative of G? Think the derivatives would go this way. The antiderivative, oh man, who knows? Does that make sense? We don't know what the antiderivative of G is. And since we don't know the antiderivative of G, there's no way we could have done the first fundamental theorem of calculus here, okay? Had we known the antiderivative of G, we could. Everybody good with that? That's the difference. That's why we didn't do the first fundamental theorem of calculus here. But it seemed like maybe we could have. All right, can we look at number 9, guys, on last night's homework? And does anybody, let me see if I have it.
I have it recorded if you want me to
Does
tell you.
anybody actually have it?
Yeah, it's going to be, you ready?
From 2 nights ago? Or
Yeah, I have it right here.
Okay, go ahead, Andrew.
It's the derivative of the integral of 1 over t squared plus 4. And then your b is x and your a is pi.
Oh, your B is X and your A is what?
Pi.
Pi. So did I write it correctly here, Andrew?
Yeah.
This is right?
Mhm.
Okay, so this is the derivative of an antiderivative. Okay, so the derivative of an antiderivative tells me to use the first fundamental theorem of calculus. What is the first fundamental theorem of calculus? You take the derivative of the top. What's the derivative of X? 1. Then you plug it in. Okay, there's no more derivatives. Then you plug it in. So wherever there's a t, if this is a t, you plug it in. Now, guys, do not plug it into the dt. Is everybody good with that? Okay, for this problem, you ignore the dt. Okay, plug it into the function t. So that's going to be 1 times 1 over x squared plus 4. Then you put a minus sign. That's just the second fundamental theorem of calculus. Then you take the derivative of the bottom. What's the derivative of pi? What's the derivative of any number? 0.
0.
So this is 0 times Then you plug in the pi. So that's 1 over pi squared plus 4. But the truth is 0 times any number is 0. So your answer is 1 over x squared plus 4.
Thank you.
Okay, you're welcome. And we're looking at number 14 and 15, I believe. Oh, wait, that doesn't look like, is that 14? Yeah, so we're looking at 14 and 15. I think that's what you guys asked for. Let me check to make sure. Check in the chat here.
On the average value theorem, does it matter which one you put as your B and which one you put as your A? As long
You
as
can pick anything as A and B, but you got to plug it into your formula correctly.
Uh,
Does that make sense? You can put in anything you want, but the thing is plugging it into your formula correctly. All right, 14 and 15. So guys, here's 14. 14 says, between the hours of 1 and 4, the speed of traffic is this. So this is the speed, okay? The question is compute the average speed, okay, from 1 to 4 p.m. When they talk about time, time is kind of confusing because you can't just always use the numbers for time because time starts or over after 12. Does that make sense? And you have to use the numbers like 13, 14, and 15. But I think this one's not bad because this is just goes from 1 to 4 p.m. So you can actually subtract those because that's 3 hours in between. Okay, if I'm given speed and I want average speed, okay, then what you do is you use the average value formula, right? So this is going to be 1 over b minus a, okay, the integral of speed, because I want the average speed of dt. Okay, so there's my formula, and this is a and this is b. Okay, usually, guys, you would pick this as a and this as b, okay? And actually, I would. Do you guys want to switch it and see that you get the same answer, or you guys want to just keep it? Just keep it, okay. So I just want to let you know, if you switch it, as long as you plug in B and A consistently here, does that make sense? As long as your B is always B, as long as your A is always A, then you'll get the same answer. You just got to be consistent about it. All right, so I'm going to use 1 and 4. So this is going to be 1, this is going to be 4, this is going to be 4, and this is going to be 1. Okay, make sure I'm plugging everything in right. It's going to be 1 over 3, the integral from 1 to 4 of my speed formula. The speed formula is here, 2t cubed minus 21t squared plus 60t plus 20 dt. And it says use your calculator to find the average speed. All right, so then you just plug this into my calculator. All right, you could do it by hand, but it says use the calculator. So I'm like, okay, force me to use my calculator. I'm good with that. So this is going to be 1/3 times this whole thing here. Okay, so let me just do this whole thing first. So that's going to be a math 9. Okay, I'm going to go from 1 to 4. Okay, the function is 2. I know it says t, but I'm going to use x's. Shh, just don't tell my calculator I'm cheating on it. Okay, minus 21. I need a minus sign. Minus 21 x squared plus 60x plus 20. Okay, make sure I put an x out here. Press enter. There's my number, but don't forget to divide by 3 or multiply by 1/3. And can you guys check me, was the answer 65.5 or not? Yes, okay. And guys, the thing with average value, the great thing about average value is the units are always the same as whatever you took the average value of. So if this is speed, then it is speed. So what is the units for speed here? Kilometers per hour. So that's your unit, okay? And that should make sense, right? Because if you think about it, remember what we did yesterday, when we said we wanted average value, like you just got some point, and you put some cereal under here, okay? And you crushed your cereal down and we got some value, but that value was just your Y value, right? So your units is still whatever your units are for your Y. It says, suppose that during a typical day in Minneapolis, the temperature is shown in the figure below. And whenever they say temperature, it's actually, I mean, whenever they give you time for the x-axis in like, you know, 3 o'clock, 4 o'clock, it's actually kind of hard to figure out because the thing about time is when you go from AM to PM, the numbers start all over. Does that make sense at the 12? So you actually have to use Army time when you're graphing it. So this is 4 AM, but this is 6 AM, and then 10 AM, then 12 AM, then, wait, am I not doing this right? No, I'm not doing it right. I'm doing a terrible job. So 4, 6, 8, like that, right? So this is 4, 8, 12. Okay, at 12, you're at noon, right? And so when it goes to, when it goes to 1 p.m., then you're 13. Does that make sense? And so since 1 p.m. is 13, then 2 p.m. is going to be 14. Then 3 p.m. is going to be 15. So guys, what's 8 p.m. going to be? 20. So the 8 p.m. is going to be 20. So you're going to actually go from 4 to 20. Okay, you're actually going to go from 4 to 20. Okay, so first make that clear. Okay, then the second thing is, what are they asking you for? It says, use a midpoint Riemann sum with 4 equal subintervals to approximate the average temperature over the time period from 4 to 20. So you're asked for average temperature, okay? What is the formula for average temperature? It's going to be 1 over b minus a of the integral from a to b of temperature, right? Isn't that what I said? If you want the average value of your dog, you'd put your dog here. Well, I want the average value of temperature, so I would put temperature here. And this is with respect to time. This is a time on the x-axis, so this is with respect to time. Okay, so what I want to do is actually figure out what a to b is. So this is time. So what is my time going from a to b? What is that? Is it 4 to 20? Okay, now keep it consistent, guys. If I say my a is 4, okay, this number here is 4, and this number here is 4. Does that make sense? Don't make your b 4 and your a 4. Does that make sense? You got to keep it consistent. And if I say my b is 20, then make this 20 and make this 20. So what I end up getting is 1 over 16 times the integral of 4 to 20 of the temperature dt. And so if I could figure this out, then I will have the answer to the problem. The thing is, I don't know the function of temperature, right? There's no equation that I can put in here, all right? But here it says use a midpoint Riemann sum with 4 equal subintervals. And guys, if I get the area under the curve here, do you guys see that that's really what this is? Isn't that what a Riemann sum is, right? If this is a graph of temperature, and it is, okay, if I get the area under the curve from temperature, that's what this red box is. Is everybody good with that? Okay, but area under the curve is such a misnomer because it's not really area under the curve. I told you guys, I confess that I've been lying to you this whole time. It's not really area under the curve. It's actually the net area under the curve, right? Pluses and minuses. If you're above the x-axis, it's going to be called plus. If you're below the x-axis, it's going to be called negative for when you're doing integrals. Integrals is really net area. Okay, so let's look at this problem. I'm going to go from 4 to 20. Okay, I want the area under the curve from 4 to 20, okay, or the area between the curve and the x-axis. How many subintervals do I want? 4, okay. So between 4 and 20, put your bases. Go ahead and draw that for me. You need 4 little bases. Do it, guys. 4 little bases, okay? Make sure you can do it. Okay, this is the first step, because if you don't do these bases right, then your whole thing is wrong. So there's one base. Here's another base. Okay, you need 4 of them. Here's another base. And then here's another base. Is everyone with me so far? We're going from 4 to 20. Okay, then you're going to grow your skyscrapers. Okay, are we doing trapezoid or no, we're doing midpoint. So midpoint means don't come from the left side. Don't come from the right side. Which side am I coming from? From the middle. Okay, so here's my base. I'm going to come from the middle, but this is kind of strange. Do you see I'm going to drop down? Is everybody good with that? I'm going to drop down and just approximate what the middle is. I'm seeing somewhere right there. Okay, I'm not approximating the middle, but approximate where I'm at on this curve. And so do you see this is my first rectangle and it's going to be negative. Is everyone good with that? Okay, so same rule. Here's my second base right here. Now it's super important that you draw your base, because if you don't draw your base right, then everything is going to be wrong after that. Okay, I'm going to come from the middle, not from the left, not from the right, but come from the middle. This time, am I going up or down? Up. Okay, so up just by a little bit. So there's my second rectangle. Okay, go ahead and draw your third rectangle, guys. And draw your fourth rectangle. Okay, my third rectangle I think is about up here. Maybe make sure you're coming up from the middle. And then my fourth rectangle, I'm going back down. Did you guys do the same thing? Okay, so my last and first rectangles are negative, and then these two middle rectangles are positive. Okay, now we just find the area. What's the area of the first rectangle? How much did I go down by? 5. Okay, so this is 5 times, what's my width here? Be careful, what's my width? 4. So that's going to be 20. Actually, negative 20, right? Okay, I'm going to say negative because it's below the x-axis. All right, my second rectangle here, what's my height of my second rectangle? 1 times, what's my width? 4. So that's just positive 4. Okay, what's my third rectangle? What's the height of it? 2. What's the width of it? Is it 4 still? Okay, so I'm getting positive 8. Okay, and then my fourth rectangle, what's the height of it? Is it negative 2 or 2 times 4? So here I'm getting negative 8. Did I do that right? 4 times 2. Yeah, I think that's right. Okay, so I'm going to add all these together. So I have 20, negative 20, plus 4, plus 8, minus 8. Do you guys get negative 16 by any chance? Okay, so I'm getting negative 16. And so here's the thing though, this box is negative 16. Is the whole thing negative 16? No, it's just this box. And so what I have to do, guys, I got negative 18 in the last class. But this is right, guys? I think we just did something a little bit different in the last class. 5 times 4. You got negative 16? Okay, so negative 16 times 1 over 16, do you see is equal to negative 1, right? So this answer is negative 1. And what is that saying? That's saying if we put cereal in all of these boxes, okay, and it's not actually the same. You can't swish it down like you did before. That the average value is going to be negative 1. You actually can't do cereal in this, okay? But on average, okay, the average temperature is going to be 1. So then what we do is we look at negative 1 because letter B says, well, the answer to letter A is answer is negative 1. And this is, it's always the, whatever your Y value unit is, that's what average value is. Okay, so if your Y is degrees, then this is degrees. I don't know what Y is. It doesn't really tell me, does it? It says temperature. Yeah, but they don't actually, oh, here it is, degrees Celsius. Do you guys see that right there? Degrees Celsius. So it's actually negative 1 degrees Celsius, okay? And you don't have to put units, but I just wanted to clarify. The average value is always the same as whatever your units for your Y is, right? Because if you think about it, when you squished all your cereal down, it was a Y value that you read off, okay? Now, the next question says, at what time does this happen? So guys, you see, this is a picture of your temperature, right? So it's just saying, when your temperature is negative 1, so it's negative 1 here, and it's negative 1 here. Does that make sense? What time does that happen at? So what does it happen at here? What's this time right here? Is that 8? Okay, so at 8 a.m. What about this time right here? It's 18. Yeah, but what's 18? 6, right? Yeah, so you subtract 12 from that. So you get 6, so 6 p.m. And so those to be your 2 times, 8 a.m. and 6 p.m. Okay. Oh, yeah, the key is just wrong. Yeah, the key is just wrong. Okay, sorry about that. So this is your answer. Okay, and also this key switch number 9 and something, right? And then also the key for tonight, number 10 should be 123, not whatever it's in there. Okay, so just FYI. I don't know. It's a trapezoid one from for the review. Okay, number 10. Number 14 on the review. This is a very common problem. Okay, what we've got is a tank with 1,000 liters in it. Okay, so you've got a tank and it's holding 1,000 liters of water. Okay, you've got a pump that's pumping water into the tank, or is it taking water out? The pump is pumped out of a holding tank where T is since the pump started. If the holding tank contains 1,000 when the pump started, how much water? It's pumped out. It's pumped out of a holding tank. Okay, so what you're gonna do is you're gonna take water out of it. Does that make sense? So whatever your answer is, do you agree it's less than 1,000? Okay, whatever your answer is. Okay, how much are you gonna pump out? Well, the pump is pumping at a rate. So the rate that the pump is pumping is 5 minus 5 e to the negative 0.012 t liters per minute. If you integrate a rate, you get an amount of change, right? So if I integrate this rate, I'll get the change in liters. See if that makes sense. Because think about it. If you integrate a rate, okay, rate, it's a function of time, all right? And so what I get is liters per minute times minute, okay, because that's what dt is. dt is minutes. The minutes will cancel out, I'll get liters. So guys, if you integrate a rate, you get an amount of change. This is gonna be liters minus liters. So it'll be like the amount, I'll just say A, the amount of water minus the amount of water. I mean, I don't know what letter it would be, but like if this were R, this would be the antiderivative of R, right? We know that because the first fundamental theorem of calculus. And what time periods do we have? Time what? Time 60, and I have another time though, 0. Does that make sense? 0 to 60. And so this is really the amount of water at 60 and the amount of water at 0. But this is just really an amount of change, right? If you integrate a rate, you get an amount of change. It's basically the first fundamental theorem of calculus. Anytime you have a rate here, and whatever it is, like this is liters per minute, then this is going to be liters. Okay, you integrate a rate, you get an amount of change. Well, I really just want to know the amount of change, right? So how do I get the amount of change? Well, I'm going to integrate this rate. So this rate is 5 minus 5e to the negative 0.12 t dt. And if I integrate this, I'll get the amount of change. So I go to my calculator, I hit math 9, okay? I go from 0 to 60, okay? And then this right here, I'm going to put my R in. So that my R is 5 minus 5 second E. Where is my E? Here. E. Oops. Negative 0.12. And I know I'm going to use X's instead of T's. You can use T's if you want. If you use a T, just make sure you put T here and a T there. But it's a lot more buttons if you push T's. So I'm just going to use X's. And I'm going to cheat on my calculator. Shh, don't tell it. All right, press enter. Okay, and that's the amount of change. So if I integrate a rate, I get an amount of change. Well, if I started out with 1,000, where am I going to be when I'm done? Actually, I guess if I wanted to, this is kind of interesting though. Water is pumped out of a holding tank where if the holding tank contains 1,000 when the pumps are, how much water does it hold? 6? Okay, yeah, I should subtract it, right? That's kind of interesting though, actually, because usually I set it up so that it, you would add it. Yeah, actually, I usually set it up for you so you would add it. Oh, I added it? Oh, oh, that's interesting. Okay, well, that's a little confusing, I think. I think the answer should be subtracted, right? Because I subtracted, right? So it should actually be 1,000 minus 258.3644. I mean, this is the real answer. Sorry, my answer is wrong then. So take 1,000 minus this. But I got to tell you, I actually should have thought about this problem more.
Really one problem. My calculator never works. I can set it up and do all that, but as I plug in my calculator, it never works. I think because I got the old one.
Are you serious?
Yeah, it doesn't give me that answer. I don't know how I plugged it in.
Okay, I'll look at your calculator. But this is what your answer is. Yeah, sorry about that. Actually, what I usually do is I usually make this a negative. Like, what would happen if I changed this to? I must not have looked at this problem before I assigned it, because I usually try to make sure this thing works out. So if I had turned this to a negative, it would have worked. Does that make sense? And that's usually what I do. I turn this to a negative. So actually, this would have been 1,000 because you start out with 1,000. And then you would add 1,000 to a negative number and you would get this number. So I apologize for this problem. In yours, it'll be really clear, you know, if this turned out to be a negative number, it would work with the first fundamental theorem of calculus, okay? So technically this should be a negative. I should have changed this to a negative. Okay. Here's 16 right here.